Thanks very much for the introduction, and thanks for inviting me to talk. Hello, everyone, and hi to the people who are joining online as well. I'm a psychologist, and I'm from King's College London, as it says. And in the past 10 years or so, in my discipline of psychology, we've learned an awful lot about the quality of data, the rigor of scientific knowledge, and where some things go very, very wrong. And I wrote a book about this that came out a couple of years ago now. And this is about this talk explains kind of the stuff we've learned in the past decade or so in psychology. And not just psychology, but in science more generally too, because scientists are obsessed with scientific journals, right? They're obsessed with publishing findings in scientific journals. These are some examples, and some very nice, colorful examples of scientific journals where scientists are desperate to publish their work. You get it on your CV. You can get lots of prestige from publishing in a scientific journal. But the problem is, and I'm going to make the case during this talk, the problem is that our obsession with publishing stuff all the time in scientific journals is ruining the quality of our research and the quality of our knowledge. I mean, we're all meant to be thinking about knowledge during this summit, and this is one of the biggest factors that can impede us getting high quality knowledge about the world. So this is a talk in many respects about what's been called the replication crisis, the problem that we are having real serious issues replicating research in our field. Let me explain. But I'm first going to show you how I got interested in the replication crisis. In 2011, when I was a PhD student, this paper came out. So this is a paper in a very prestigious psychology journal, the Journal of Personality and Social Psychology, and it was making a contribution to the scientific literature, and that contribution was that psychic powers exist, right? That people can have psychic abilities with their mind to be able to sense the future, right? So you can, as you can imagine, people were quite surprised by this, and surprised that it would be published in a top scientific journal. And so here's an example of what one of the studies in this paper looked like. You see a list of words on the screen one at a time: apple, chair, planet, whatever. Just a list of boring words on the screen. And then you have to do a memory test. You have to remember as many of those words as you possibly could. Then the computer randomly selects half of those words and shows you them all again. And then that's it. That's the end of the experiment. And what was claimed in this experiment was that the words that the people were about to see for the second time were remembered better on the test. So it's a bit kind of mind-blowing, but it's a bit like you study for an exam, then you sit the exam, and then after the exam, you go home and do some more studying, and that extra studying somehow goes back in time to help you get better results on the exam. So it's like, it doesn't make any sense. It's bizarre. And yet, this was published in a scientific journal, right? This was it's a piece of the scientific literature. So we thought this was rather bizarre. We ran the same experiment again. We tried to replicate the experiment. We ran the exact same thing again in our laboratory in Edinburgh, in Scotland. And, well, you might be unsurprised to learn that we didn't find any evidence for psychic abilities, right? We found that all the words were memorized just as well as each other. There's no evidence of anything going back in time or anything like that, anything weird like that. So we sent it off to the same journal that had published the original paper. And this is the response that we got. First of all, you're being rejected. We reject your paper from the journal. And the basic issue is this journal does not publish replication studies, whether successful or unsuccessful. Instead, we seek to publish papers that make a substantive, novel, theoretical contribution. And I think this reveals a really serious problem in the way that we do scientific research, certainly the way that we publish scientific research. journals are interested in publishing exciting, novel, flashy, even weird findings, but they're not interested in publishing a paper when someone else comes along and says, well, actually, maybe that's not right. So we have this really serious problem with obsession with novelty, and we're far less interested in more rigorous, perhaps, but more boring results. And we were saying psychic powers don't exist. And that's, boring, but perhaps more realistic. Around the same time, in 2011, this guy was becoming very famous. This is Diederik Stapel, who was a social psychologist at Tilburg University in the Netherlands. And he had published very many papers in lots of different psychology journals, and not just psychology journals, but some very prestigious journals like Science, which is one of the top scientific journals in the whole world, on things like the messiness of your desk predicts how racist you are, like things like that, like social psychology findings that could be distilled really easily and put into a kind of newspaper headline, like headline-ready findings. People love this kind of stuff in social psychology research. The only problem was that all his research was fake. He had made up all the research. He actually sat down with an Excel spreadsheet and just typed in the numbers that he wanted for his experiments that he had claimed to do, and then sent them off to all these very prestigious journals, got publications based on completely fake, fabricated research. And this all came out, and in 2011, here's a notice from the journal Science where they retracted his paper because it included fabrication of data, and he had well over 50 papers retracted from the scientific literature. One of the most prolific fraudsters ever. We'll come to fraudsters in just a moment. But this, plus our experience with the psychic paper, plus a few other things that happened at the same time, got psychologists really questioning how much they could trust the knowledge that they had gained, the knowledge they thought they had gained in their field, in the scientific literature. And so they started asking questions. They started doing replication studies. They started going back, trying to repeat experiments that had previously been published in the literature in order to see how reliable that knowledge really was. And you got studies like this one. This is from 2015, and you don't need to understand necessarily the specific statistics here, but the point is that when people went to replicate studies to try and find exactly the same results again, they could only do so in about half of the cases, right? So about half of the literature, when we try in an independent lab to do the same experiment again and get the same results, you don't get the same result. You get something different. You get something that's statistically non-significant when it was statistically significant before, or vice versa. You don't find the same result overall about 50% of the time. And that happened in psychology, but it started to spread elsewhere. So economics, they have their own replication crisis. Artificial intelligence have seen similar things, problems with replicating the effects of the results from algorithms, for instance. In cancer research, they had a very similar story where they set out to replicate 50 studies in cancer research. They couldn't even begin to replicate even one of them because the original scientists had not written enough details in their experiment about how they did their study. So nobody could actually come along and repeat that. I mean, what's the point of a scientific paper if someone can read the whole thing and still not know how you did the study? But that happened in all of these cases. And then eventually they got to replicate some of them, and there was a kind of a mixed bag of findings there. And then there's this book which came out a few years ago called about medical reversal, which is about clinical research where often a clinical trial comes along and reverses all what we thought we knew about a particular medical technique, whether that's treating people who have just had a heart attack or a stroke, what we do with kids' allergies, whether you should give them peanuts or not, for instance. Our knowledge of that has completely shifted round, and in various other ways too. And so we have this problem of medical reversal, which is basically the replication crisis in medicine. And a lot of scientists agree. So there was this poll, admittedly an unscientific poll in 2016 in Nature, where essentially lots of scientists said that they agree that there's a significant crisis of reproducibility or replicability in their field. And 38% said there was a slight crisis. I don't really know what that means. That's a strange way of putting it. But they said there was at least a slight crisis in their field. And if you look in the scientific literature, there's loads and loads and loads of discussion now on the crisis and all the problems that we're having in science, of replicating results, of really relying on the knowledge that we think is there. And here, I think, are the 4 main reasons why we have so much trouble trusting the scientific literature. Fraud, bias, negligence, and hype. I'm going to give you some examples of each kind of this. First of all, this guy. This is Yoshitaka Fuji, who is the world's most prolific scientific fraudster, right? He has had 183 papers retracted from the scientific literature, if you can believe that. He's an anesthesiologist who claimed that he was running anesthesiology trials on various different new techniques and things. None of them ever happened. They're actually all fake, and he's had to have 183 papers retracted from the literature, and he comes in at the top of the leaderboards of the most retracted scientists. This is like the opposite of the Nobel Prize. It's like the worst possible list you can be on as a scientist. And you can see there, he's got 183 retractions. Diederik Stapel, who I mentioned earlier, is there at number 6. He's got 58 papers retracted from the scientific literature. Can you imagine? Can you imagine writing 58 papers entirely based on fake data? And so many more. Lots of different fields, as you can see. Psychology is in there, my own field, but anesthesiology keeps coming up, computer science, various other different fields, from soft to hard sciences. Scientists just love, seemingly, committing fraud. And it's not just data that they commit fraud with. They commit fraud with images quite often. So it's very, very common to see scientific images, and you might recognize these kind of things if you've seen news reports or read papers on genetics, biochemistry. You see these kind of blot images, and these are from experiments to show the particular chemicals that are present in a result from an experiment. And it looks as if this is all just a bunch of random dots, right? It looks like these are really like the results of a chemical analysis. But in fact, if you look more closely, and this was a paper that was published in the scientific literature, this is actually photoshopped, right? So the scientists have gone in, taken these pictures and photoshopped them to make it look like they got results, which in fact they never got, right? This is a fake image. This paper had to be retracted from a scientific journal, because it had fake data and fake images. And the problem of fake images is becoming much more common as well. So you can see there, in some years when this was looked at, about 5% of papers had some kind of problematic image. Now, that's not always due to fraud, but some kind of image that looked like it might have been photoshopped, duplicated, recolored, cropped in some way that made it not actually a realistic representation of what had gone on in the experiment. So, I've made it sound like lots of scientists commit fraud, which they do, but the question is how many? How many, what percentage of scientists actually, do this? And if you define fraud as fabricating or falsifying research data, and you just ask scientists, have you ever done that? About 2%, just under 2% of them say that, yeah, I have done that at some point in my career, I have committed fraud, 1.97%. If you ask them, do you know anyone else who has committed fraud? About 14% of them say, yeah, I think I know someone who's done that. Now, I suspect the first number is an underestimate, and the second number, there's reasons to think it might be an overestimate. Maybe you really hate someone in the next lab over and you want to accuse them of fraud or whatever. But still, even if these numbers are anywhere in the ballpark of being accurate, they're quite scary, right? That's the number of scientists commit fraud. But still, it's a minority, right? It's a minority of cases. Not it can't be the case that fraud is explaining all these replication issues that I mentioned at the start. But that's where I got those numbers from. But it's weird because if you look at the scientific literature, it kind of looks as if scientists have been committing fraud to get the results they want. This is a comparison of lots of different fields that shows the percentage of papers that report a positive result. Right? You'd think that scientists would be doing experiments, and sometimes they'd find a result that they expected, sometimes they wouldn't find a result they expected, and maybe it wouldn't be 50-50 because you're making an educated guess, you're not just randomly doing stuff, but you maybe wouldn't expect, as in psychiatry and psychology, that over 90% of experiments find the result that the scientists predicted, right? And that's the case. Over 90%, and you can see that it's lower in other fields, but not that much lower in other areas of science. Now, there's many different reasons for this, but it certainly points in the direction that we're not getting a realistic view of all the research that's being done, and part of that is due to what's known as publication bias, right? As we saw at the very start, journals are interested in publishing exciting, positive results, but they're not so interested in publishing results that are boring. Those get shoved in the file drawer. Those get never seen again, right? So publication bias is one part of this. But as I also said at the start, and I don't want to contradict myself, scientists love publishing papers, right? I mentioned that scientists love having papers on their CV and getting them into these shiny, colorful journals and so on. So you can't just shove the study in the file drawer, and you maybe want to still get something out of it. So instead, there are ways, consciously or unconsciously, I mean, I think in many cases unconsciously, of manipulating the data so that you find the result you want, even if it's not actually there. Here's an example of this. Now, this is one of the most famous TED Talks ever. I think it's the second most watched TED Talk of all time. It's by Amy Cuddy, and it's about this idea of power posing. You may have seen this power posing idea. 64 million people have seen it on the TED website, and another 21 million on YouTube. So that's an awful lot of people. And the idea here is that you do a power pose before your some kind of stressful event, like an interview or something like that, and it will it'll improve your risk taking. It'll make you feel more powerful. Your hormones will improve. All this kind of stuff. And this became an absolute sensation. There was a best-selling book based on it as well. The only problem is when people came along and tried to independently replicate the results, they couldn't do so, right? And my impression of the overall literature is that the vast majority of the things that were claimed in this very famous TED Talk don't hold up when independent labs come along to replicate them. And the fascinating thing about this is it didn't just end there. The first author of the paper, so not Amy Cuddy, who publicized this stuff, but the first author of the paper, who's Dana Carney, she's at Berkeley. Oh, there we go. She wrote an amazing letter saying, as the evidence has come in over the past years, my views have updated, and I no longer believe this stuff anymore. I published this paper, I caused this huge sensation, but I no longer believe it. And I think that's an amazing example of scientific integrity. But here's what she said. She said, first of all, we had a tiny sample size in our experiment. We had 42 people. This is not something that you can use, rely on to build a solid research finding. Initially, they just looked at risk taking, but then they added lots of other outcomes as they went along. They checked the statistical significance of the effect along the way. They kept rerunning the analysis and then adding a few more participants, then running it again, and then adding a few more participants, running it again and again and again and again and again, until they found the result that they wanted. And obviously, every time you run a statistical analysis, you're rolling the dice, and you might end up with a false positive finding. They excluded people and didn't report it. They tried various different statistical tests and just picked the one that worked. They dropped the outliers, from some analyses, but not others. So it was essentially an extremely, and they asked lots and lots of questions and then just reported the ones that suited them. So she admitted all this, and this is an example of what's been called, these have been called questionable research practices, right? They're not fraud necessarily, because they're kind of borderline, maybe it's a good, maybe it's the right way to do research, maybe it's not. They're not fraud necessarily, but you can fool yourself into thinking that these are good ways to do research, when in fact, they're increasing the chances that you're going to find a false positive result. So these questionable research practices have been studied in surveys where you can see that in some cases majorities of researchers across many different fields, I'm not going to go through all of these, not really got time to go through them all, but say that they've done something which we know is a kind of dodgy way to do your research. But people do it anyway because they feel pressured to find the result that either they want, their boss wants, they think would benefit the world, and it's not actually what the data shows. Okay, so that's bias. We've done fraud, we've done bias. Now let's talk about negligence. Here is an algorithm that checked the evidence in thousands of psychology papers. And basically, I don't want to, again, I realize I'm running fairly short on time, so I don't want to go into all the detail, but to cut a long story short here, this found loads and loads of typos in the numbers of published papers in the literature, right? You think scientific papers would be checked and checked and double-checked, and you would never, you'd be able to trust the data that's in there, but in fact, they're full of errors, they're full of typos, and in some cases, in some very scary proportion of those cases, the typos actually flip the results. So if you corrected the typo, the result would no longer be statistically significant, for instance. So these are quite scary findings as well. And another thing that scientists like to do, of course, if they've definitely not made a mistake, they don't want to muck about with the results, there's no fraud involved, but they still want to claim that they found a result, is that they can spin their results, right? So they can add spin to their paper to make it sound like they've found something when in fact they haven't. And this is something you have to look out for when you're reading scientific papers, because there's an awful lot of spin goes on. There's no one actually really stopping you from spinning your results. So here's, when you find a result that isn't statistically significant, so that p-value that scientists use, they want the p-value to be lower than 0.05, and that means that the result is statistically significant. You've encountered this phrase, I'm sure, many times. But when it isn't statistically significant, here are some of the genuine phrases that scientists have used to make it sound like the result is significant. A trend that approached significance. A trend significance level, narrowly eluded statistical significance, barely escaped statistical significance, fairly significant, significantly significant, hovering close to significance, all but significant, approaching marginal significance, very closely brushed the limit of statistical significance, and my favorite, which is not absolutely significant, but very probably so. Now, these are all ways of saying, we haven't found the result we want, but I want to write it as if I want to convince you that there is actually something there, when in fact there isn't, right? And we think of scientists as being like super objective, right? But actually, this clearly shows the opposite. I'm going to skip this on just to say that they often make mistakes in press releases. So when they're putting results out into the world, they often hype up their results beyond what the data can actually show. And I don't like to name names necessarily, but here are 3 examples of books by very prestigious professors at top universities in the US, who I think in all these cases there is a kernel of truth to what they claim, right? It's not that these are made up or completely wrong, but they're hyped up so that some interesting finding is made to sound as if it's the most important thing ever, rather than just something that's interesting and worth discussing, right? So there's an awful lot of hype, even at the very highest levels of academia, or perhaps even more so at the highest levels of academia. And this just puts it all together. This is an amazingly dispiriting figure from a study where they looked at the number of papers that were had positive and negative results in trials of antidepressant drugs. So that's on the very left-hand side there. You can see that there were about half the studies were red, they had negative results, and about half the studies were green, had positive results. And almost all the positive results got published in a journal, but only half of the negative results did, right? So already we're not seeing half of the trials that showed that the antidepressant drug didn't work. So we're already getting a distorted view of what the real evidence shows. In many of the cases, when they found a negative result, the scientists just switched it to a different thing. So they were planning on analyzing this particular measure of depression, but then they just changed it to another one because it didn't show the result they wanted. So you're having these questionable research practices. This also shows that in many of the cases, even when they found a negative result, they wrote it up as if it was positive. So they spun it to sound more positive. And then the final insult to injury at the end is that the studies that were positive were cited much more by other scientists than the ones that were negative, right? So we're obsessed with positive findings. We're obsessed with finding exciting results that show that we're well on our way to dealing with depression or whatever it is. But actually, the reality can be quite different. If you see right from the very beginning what the science actually looks like, and then what we see when we read the scientific literature. Okay, just a few points to kind of finish that off. My friend Zach Wintersmith made a comic from when my book came out. He made a comic of my. This is meant to be me talking about science and stuff. And there's a whole long comic strip that you can get at that link, and it's all it's quite a fun summary. The reason that this is happening is not because science is wrong, not because the scientific method is wrong, not because the scientific process is wrong, but because of academia and, to some extent, industry. But the places that we do science push us away from actually getting correct results and push us towards fraud, bias, negligence, and hype. That's my thesis. That's the thesis that I put forward in my book, Science Fictions, which I forgot to put on any of these slides, but it's available at all good bookshops. And a lot of the problem is these journals, right? To go back to these journals that I mentioned before. Hyping up your findings to try and get them into the top journals, try and catch the eye of editors. You know, in some cases, making up your findings from scratch because you desperately want to get these publications. Sometimes your job requires you to get lots and lots of these publications, right? So you get people churning out endless low-quality papers just to keep their job. You get people fabricating or falsifying results in order to get into the higher impact, as they're called, journals, so that they can get a promotion or become more famous, well-known in science. It's not good for science. It might be good for your individual career, but it's not good for science. So just a very, very brief run through some of the things journals are doing. I have seen some progress. That's been a gloomy picture that I've painted so far, but I have seen some progress in the last 10 years. A lot of journals are now adopting these kind of ideas. They're requiring people to publish their data online, make their data open, right? And if you've falsified your data, maybe you don't want to publish it online, so that's a way of deterring fraudsters by making them publish all their data online. Pre-registering the study, I'll come back to that in just a moment. Doing replication studies and so on. A lot of journals that used to say we don't like replication studies, after having seen all the problems that I just described, are now actually saying we're interested in replication studies sometimes. There's this really interesting graph from a paper quite a few years ago, but it was remade recently on the Our World in Data website, which shows that after registration was brought in for certain clinical trials, so after you had to say what analyses you were doing, it stops you from mucking about with the data, stops you from playing around and just finding any old thing in the data. After registration, mysteriously, studies that were getting positive results all the time started getting null results, started getting results that were not statistically significant. And it's probably the case, and this, by the way, is also the case in psychology, where when you write down your plan, you're much less likely to get those positive results. And it implies to me that getting positive results is something that comes about when you don't have a plan and you can just satisfy yourself by mucking around in the data. There's now websites like the Open Science Framework where you can post your data, you can register your study, you can update your registrations, you can do all sorts of different things. Now, the technology that's available now online makes it vastly easier to make your research transparent and open in ways that you just couldn't do 10 years ago. And these are very simple websites, repositories, and so on, and they're becoming better used in many different fields of research. You don't need to be super high tech, you just need to make the technology accessible to people. There are journals appearing that are changing their practices. There are journals, first of all, that are studying the kind of stuff that I've talked about in this talk. So they're doing meta-science, or meta-psychology, meta-research, science about science, so we understand the ways that it can go wrong and the ways that we can fix it. And there are journals that are changing the way that they accept papers, changing the way that they publish research in order to make it open, transparent, and to stop a lot of these dodgy things that happen behind the scenes from occurring. And I'm optimistic that it really could make a difference. There are also lots of organizations that are getting together where people are talking about open science, open data, open access, open research, and improving the quality of our research. These are just a few examples from the UK and the US. So the discussion is happening about this stuff, and this is what we're doing right here. We're talking about these issues. And just one final thing, which is to say, you don't have to, I really want to underline that I'm not attacking science here. I'm not saying, oh, you don't let's not believe in the vaccine trials or something because science is dodgy. Not at all, not at all. The vaccine trials were actually done avoiding a lot of these problems because they were very transparent. They knew that they would get extreme scrutiny, right? So they were very, very transparent. So by following the sorts of things I'm talking about, they actually managed to do a great job. So you don't need to drop your interest in science or start mistrusting science. Everyone just has to raise their standards. That's what I've been arguing for today. So thank you very much for listening. Feel free to get in touch. I'm happy to share these slides. Thank you once again. Thanks. I think I have time for some questions if anyone wants to ask. Yeah.
Thank you very much, Professor Ritchie, for fascinating
Thank you.
Thoughts and based on substance and science. First of all, I come from industry. My name is Walid Hussein. I'm from the Saudi Arabian oil company, Saudi Aramco. But I've been, because of the virtue of the work I'm doing, I'm engaged with academia and research centers all the time. Exactly, you explained it perfectly. We see that researchers, scientists, faculty members, their focus is on publication. And that's worldwide, whether it's in this part of the world, or the UK, or in the North America. The number one priority when it goes to academia is number of publications, then patents and what have you. Yep. So the concern that I found from your presentation, what academia could do to instill the spirit of ethics, integrity, and making sure that the credibility that the academic sector and the research enterprises have gained through centuries will not be shattered with regrettable practices that some of the members of this community acts on. The concern is this. So you have young generation who are going into research in different disciplines and bodies of knowledge. And you want to instill in them that kind of ethics and integrity to make sure that when they consider for academic promotions and opportunities, that ethics and integrity is indispensable for their career progression, and they are doing disfavor for themselves and the research enterprises they belong to, and in fact, the entire sector that might affect. So what are your thoughts about this?
Yeah, it's a great question. It's a great question, and I think it has lots and lots of different answers. So I think it has answers from the bottom up. So we're, as a community of scientists, people are much more aware of these issues now, and they're talking about them. You look at social media, scientists are discussing these kind of things and saying, was this paper pre-registered and blah. So they're talking about these kind of techniques from the bottom up. As I say, they're building these. We're building these organizations. Like we have you know, even just thinking on the very local level, in our department, we have a kind of open science club where there's a talk each week from someone who talks about, you know, ways to make your data more open. So that's the bottom up. But there's also top-down things that need to happen. So I mentioned that some of these journals are changing the way they publish papers. That's one thing. But as you suggested, I think universities could do a lot more to change this. So hiring practices, instead of being based on, you know, how many papers did you publish in the last year, or how much grant income did you bring in the last year, we could downweight that stuff and instead upweight your general contributions to the scientific literature. Did you do a replication study? Did you produce a tool that helps people make their research more robust in some way? Did you create a data set that you've shared with people? Whatever it is. I mean, I think we want to be more pluralistic about what we consider a contribution to the scientific literature, and not just publication, publication, publication all the time. So that's one thing. I think funders also play a role. So instead of saying, we want, you know, we're going to fund your research and we want you to make sure that you publish it in Nature or Science or whatever. Instead, we want to make sure that you publish it in an open way, that you have the data online for other people to check, that you share your results, that you share the statistical code that you wrote to analyze the results, whatever it is. So I think there's bottom-up and top-down ways. Some of them will work better than others, and I think just having this conversation is part of it. Just you know, you and I talking about this, whatever. People being more aware of it, and I also think there's social pressures that we could have. Like, I just think, we don't like to say it, it's not a very nice thing to say, but shaming people who you know, do bad practices with their data, especially fraudsters. I mean, they're shamed, obviously enough, but there are people whose research maybe blends into fraud, or certainly people who hype up way beyond the data. I think we could do more in criticizing them and going back to the kind of ideal of science, which is that we're, you know, unafraid to criticize anything that goes against, you know, the data at any given time. So lots of different answers to the question, and I think we're going to need to deal with them all if we're going to really make some progress on this. Yeah?
I'm a researcher. So basically, I would like to ask is, I mean, that's a good question what the Aranco gentleman asked. We should encourage people to also say that this research is not coming to the expectations we had.
Yes.
So if that is allowed, then it doesn't matter. Because you're looking, you have a hypothesis, you're working both sides of the hypothesis. Someone agrees, someone disagrees with the justification.
Yes.
And the replicacy can be not just a replicacy, because the sample is different. So it's actually a new one.
Yep.
Especially in psychology, if I have a different sample and I do everything same, it is a different result. It's a new research, in fact, according to me. So these are some of the additions I just wanted to comment.
Yeah. No, I think the first part of what you said, I totally agree. At the moment, you know, you view this thing, this publication, and it's this sort of standalone. Oh, right, we've got to be quick. Yeah. You view it as this standalone thing where it's the end. You know, it's the end of the process. You've published your paper. That's it. And it's really difficult to do a correction or sometimes a retraction on that. If we use technology to instead have papers that were kind of living documents that you update sometimes, and new data sometimes comes in and it alters what we think, I feel like we would have a more healthy attitude to errors and making mistakes and just admitting that things didn't turn out the way we wanted. And I also think that journals, there's this idea of a registered report, right, which is instead of writing your paper and sending it to a journal, you plan your study and then send it to a journal, and then the journal says, if we agree that this is a good enough methodology, we'll publish it regardless of the result. And I think that's a revolution in the way that we publish science. So I would encourage anyone to look that up. Registered reports, they're called. Lots of journals are doing that now. And it's kind of obvious to me that that's how we should be doing science. The journal should want the paper not on the basis of its results, but on its methodology. And I think that would make a huge difference. So yeah, thank you for that. I think we're out of time. So thanks very much again for listening. Thanks, everyone.